I'm a math teacher and I'm not supposed to say this, but I think fractions are hella annoying. I don't like them any more than my students do. So I am going to show you how to kill fractions and make all these problems a little bit easier to work with, and we are going to start right now. In order to understand how I'm going to kill fractions and how that works, you do need to understand what happens when you multiply a fraction times a whole number. And not just any whole number, we're going to multiply it times the number that's in the denominator. Well, this is how you were taught how to do it. First thing you have to do is take that whole number and put it over 1, because you multiply a fraction times a fraction. Then we multiply the numerators. 2 times 3 is 6, and 3 times 3 is 1. 6 over 3 is the same thing as 6 divided by 3, and that equals 2. Well, what's the 2? Hey, the 2 is the numerator. It's going to happen like this every single time. In high school, we start teaching people this shortcut, where you are multiplying a fraction times its denominator. That's how you clear the fraction. That's what we call it. You're going to end up with just the numerator as the answer, no fractions. That's called killing a fraction in my classroom. Well, let's take something like 3/5 plus 1/4. Let's run through this the way we're taught how to do it, and that is by using a common denominator. You find the common denominator by multiplying the two numerators together. That's one way to do it. So if I take 3/5 and multiply it times 4 over 4, I have to use 4 over 4 because 4 divided by 4 is 1. I'm not really changing the value of 3/5 if I multiply it times 1. It's just going to look different and have a different denominator. For 1/4, we have to multiply times 5 over 5. Same thing. Doesn't change the value, just changes what it looks like. Now multiply the numerators and multiply the denominators, and you end up with 12 over 20 plus 5 over 20, and then you add the numerators and you have 17 over 20. This is the common denominator method. This is the way everybody teaches us how to do it. But as an upper level math teacher, I'm telling you, people forget this. We're always having to go back and review this all the time. So I started thinking, what would happen if we killed these fractions? How would we do that? I'm going to do the same problem, but I'm going to do it a different way. We are looking for an answer, so I just called the answer x, and I made this an equation. Why? Because when you have equations, you have a superpower called do it on both sides. So I'm rewriting, and I'm going to start killing fractions by doing things on both sides. And the first thing I'm going to do is multiply both sides by 5. Why? Because that 3/5 has a denominator of 5, and I want to kill that fraction first. I'm not going to do them both at the same time. You could, but I'm doing them one step at a time. That 5 is going to cancel the denominator and kill that fraction. All that's going to be left there is a 3. So I end up with 3, and then when you multiply 5 times 1/4, you get 5/4, and when you multiply 5 times x, you get 5x. Now, if this 5/4 is like what I did is I took 5 over 1 and I multiplied it times 1 over 4. That's 5 over 4. All right, now we have another fraction to kill, and that's the 5/4. So I'm going to do the same thing again. I'm going to multiply both sides times something, and I'm going to be very strategic about what the something is. It's going to be the denominator of the fraction that I want to kill. Boom. Now, you still have to multiply 4 times everything, so I have to multiply the 4 times the 3 as well, and that's going to be 12. When I multiply the 4 times 5/4, it's just the 5, and when I multiply 4 times 5x, it's 20x. Add 12 and 5, you get 17. Now solve for x by dividing by 20, and there is the same answer. I'm not saying this is a better way to do this. This is definitely option B. It's not less work, but if you forget how to do common denominators, just kill all the fractions using this technique that we learned in algebra. You get the fraction at the end when you solve for x. It definitely helps a lot in my algebra class when you're doing a problem like this. We want to convert this equation that's in point-slope form into slope-intercept form, which is a fancy way of saying we need to solve for y. That 4/5 as a slope is going to create all kinds of fractions. If you're triggered by fractions, here's your trigger warning, because I'm just going to show this to you really fast. I'm not even going to talk. Watch. So in slope-intercept form, y equals 4/5 x minus 7/5 is the answer. But every single line has fractions in it, and you have to convert a whole number to fractions and find common denominators and do all of that. It's just my experience working with high school students that not everybody is going to get all the way through that problem. What I taught my kids to do with this problem is kill the fraction before we even start. Y plus 3 on the left side, I'm leaving that alone for just a moment. Let's look at the right side. We have two numbers multiplied. Even though it looks like 3, it's really only 2. 4/5 is a number, and this thing in parentheses is another number. That's why the parentheses are grouping it. That's two things being multiplied together. I'm going to multiply this side by 5. Because I want to cancel that denominator. I want to kill the 4/5 fraction. Because I multiplied this side of the equation times 5, I have to multiply the other side of the equation times 5. So I do have to group up that y plus 3. Now the next line is going to include the distributive property on this side. We end up with 5y plus 15 equals, the 4 comes down as a whole number now because I killed that fraction. And we still have the x plus 2. So let's run another distributive property here. We get 5y plus 15 equals 4x plus 8. Now we need to solve for y. We're going to start doing that by subtracting 15 from both sides. And our next line is 5y equals 4x minus 7. We need to be in slope-intercept form, which is not 5y equals something, but actually 1y equals something. So I need to divide everything by 5 at this point. We still end up with fractions because that is the answer, but we did it without having to use common denominators, and we did it in fewer steps. If you like how I'm explaining math, if you like some of my inside secret tricks to making things a little easier, go ahead and subscribe to the channel because I'm going to keep putting out videos like this as I think of them. Check out the algebra playlist. It's right here. If you'd like to check out the geometry playlist, it is right here. Thank you for watching, and I will see you next time.